Hello everyone. So in last lecture we have covered the code converter. Okay, so in today's lecture we will cover the comparator, the 1 bit comparator and 2 bit comparator using logic gates. So our aim is to verify the truth table of 1 bit and 2 bit comparator using logic gates. So a brief introduction regarding the comparator, or you can say n-bit comparator, I will discuss in the theory portion of the 1 bit and 2 bit comparator using logic gates, and then we will simulate these two comparator in the simulation part. Okay, so what is basically a digital comparator? Or so a magnitude digital comparator is a combinational circuit that compares two digital or binary numbers in order to find out whether one binary number is equal, less than, or greater than the other binary number. So the possible combination between two bits is that if there are two bits A and B, so A can be greater than B, A can be less than B, or A is equal to B. Okay, so the number is equal, less than, or greater than the other binary number. So we have to find out comparison, the comparison between these two bits A and B. So we logically design a circuit for which we have two inputs, one for A and other for B, and have three outputs. So we have three outputs: A greater than B, A equal to B, and A less than B. Now, if we have two inputs A and B, then the possible combinations are 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so for A and B, these are the four possible combinations. Now we have to compare A and B. So here A is equal to 0, B is equal to 0. So it means A is equal to B. So then the output of A equal to B will be high, means it is equal to 1. Now, if A is 0, B equal to 1, then here A is less than B. Okay, so A is less than will be high, and the other two outputs A equal to B and A greater than B is equal to will be equal to 0. Now the third is A equal to 1 and B equal to 0. So simply here A is greater than B, so the output A is greater than B will be high, and the rest two will be 0. For A equal to 1 and B equal to 1, again both A and B are equal, so A equal to B will be high and the other two will be 0. So this is basically the truth table of the 1 bit comparator, because we are comparing single bit, 1 bit of input A with the 1 bit input of B. Clear? Okay, so now we can find out the expression for A greater than B, A equal to B, and A less than B. So this is basically the logic circuit of the 1 bit comparator. In the same way, if I am interested to design a 2-bit magnitude comparator, so basically the work of 2-bit magnitude comparator is to compare two inputs, two input bits like A1, A0 is basically related to input A. B1, B0 are the two inputs or two bits of input B. Okay, so here we are comparing input A with input B. So we are basically comparing two bits of input A with the two inputs of input bits of input B. Clear? So it consists of four inputs and three outputs. So output, the number of outputs will be same. A is less than B, A is equal to B, and A greater than B. But here the number of inputs are four. So possible combinations will be 0, 0, 0, 0, 2, 1, 1, 1, 1. So 16, total 16 combinations for input and three outputs: A less than B, A equal to B, and A greater than B. Now, in the same way as we have compared the 1-bit comparator, or we have designed 1-bit comparator, we can simply find out the expression for 2-bit comparator by simply comparing these two inputs A and B. Clear? So this is all about the theory portion of the 1 bit and 2 bit comparator. Now with the help of simulator, we will try to simulate, or we will check the possible outcomes for a particular combination of inputs. So just click on the simulation tab. So there are two basically comparators. So first we will try to simulate 1 bit comparator. So this is the circuit diagram of 1 bit comparator. Okay. So on the left hand side there is a list of instruction. First we have to follow all these instructions. So switch on the power supply button. First is. Second, press switch 1 for input A and switch 2 for input B. So the on state is green color and the off state is red. Now when the input A is greater than input B, LED 1 lights up. And when input A is less than B, LED 2 lights up. When the input A is equal to B, LED 3 lights up. Okay. So there are three LEDs, LED 1, LED 2, LED 3. And for these LEDs, the outputs are already defined, that for A greater than B, it will glow. For A less than B, LED 2 will glow, and for A equal to B, LED 3 will glow. Okay. Then the LED in off state and the LED is in on state. Simply, so click on add button to add the data. So if we are interested to add all these inputs or bits information into our truth table, then we have to click on the add button. Repeat step 2 to 4 for another set of data. So we can enter a number of inputs. Simply, if we have two inputs, then the possible output combinations will be 4. So 0 0 0 1 1 1 1 0. Okay. So first switch on the power supply. Now apply the values of A and B. So first of all, we will apply A equal to B. Okay, so just see LED 3 is now glowing. So by clicking on add button, for A equal to 1, B equal to 1, your output A equal to B equal to 1. Okay, now click on B. So here A is equal to 1, B is equal to 0. So your LED 1 is glowing. So A is greater than B. By clicking on add, you can just enter these values into your truth table. So A equal to 1, B equal to 0. So A is greater than B. Now the reverse, A is equal to 0, B is equal to 1, LED 2 is glowing. You can add these values into your truth table. Okay. Now both are 0. So again LED 3 is glowing. You can click on add button. So the entries are A equal to 0, B equal to 0 and A equal to B equal to 1. Okay. So with the help of this simulation, you can easily understand the working of 1 bit comparator, 2 bit comparator, or you can easily design, you can easily understand the working of any combinational, any sequential circuit. Okay. So these virtual labs are really very helpful for understanding the logics, the designing of combinational and sequential circuit without any physical lab. Okay, so I hope you got my point. Uh, the comparator, 1 bit comparator and 2 bit comparator. Similarly, you can simulate the 2 bit comparator in the simulation part. You just click on the simulation. So there is a 2 bit comparator. You can simply check out the operation of this A and B inputs for 2 bits comparison. Okay. Okay. So thank you for watching this. For today's, it is sufficient, I think, for comparator. Thank you.